All right, so we are going to be starting Unit 6 today, and this unit is all about transformations. So we are going to be graphing images, and then we are going to be moving them around or making them bigger and smaller while using our math vocabulary. The first one that we are going to work on is translations, and this one is usually the easiest one. For translations, we are going to be moving the shapes left, right, up, and down. And some important vocabulary that you're going to need is image, pre-image, and then initial point. So for an image, it is a point, shape, or an object. And then this is going to be after a transformation. And a transformation, again, is just some type of movement. So a key word here is after a transformation. And when we're labeling these points, we're going to use the same letter that was on the object before, but we're going to add a prime mark after it. So for an example, if we had points A, B, and C to start with, we would label them for the image as A prime, B prime, and C prime. And if we moved a shape more than once, then we would use a second prime for the second time we move it. So that would be like A double prime, B double prime, and C double prime. So an image is after the transformation. So if you are given a rule, you would follow the rule to get to the image. Oops, sorry. So we follow rules. Then our pre-image, that is the point, shape, or object before a transformation. Before. So for a pre-image, we would just label those with the letters that we would start with. So just A, B, and C. So no prime marks on there. And if we are looking to get to the pre-image, for this, we do the opposite of the rule. So if they give you the image and they ask you where would the pre-image points be, you would do the opposite that they gave you. Okay, and then the last one is initial point. This is just our starting point. Awesome. So that's the vocabulary you're going to need for this one. And then again, if you don't remember, our translate, that's moving up, down, left, and right. Now we're going to do an example. So we're going to be doing a lot of graphing this chapter. So for example 1, they want us to graph quadrilateral A, B, C, D, and they give us the vertexes. So when you graph them, make sure you are labeling the points because the labels are going to be worth points on your test or your quiz. So for this first one, they gave us point A at -2, 6. So we go left 2, up 6. Label that one A. This is our pre-image, so we just use the regular letters. B is at 2, 4. C is at 2, 1. And then D is at -2, 3. So then we connect them. It is a 4-sided shape or a quadrilateral. Okay. So then we're going to find the image of each vertex after the translation. So this is a translation rule. So if you are asked to write a translation rule, this is what it's going to look like. And with the translation rule, it always starts with the regular or the initial point, X, Y, in parentheses, and then the arrow tells us what we're going to be doing. And then they're going to tell you what change is going to happen with the x values and then what change is going to happen with the y values. So for these, in our rules, again, we have our x, y. They gave us the rule x plus 3 and y minus 3. So for all of our x values, because it's a plus 3, plus means we're moving to the right. If it was a minus, then we would move to the left. But because this one's a plus 3, we are going to move all of our points 3 to the right. Then if we look at what we're going to do to the y's, for the y's, if we're adding, we're going to move it up. If we're subtracting, we're going to move it down. And this one, we're subtracting 3. So then we would move it down 3 units. So we're going to go to all of our points. So let's start with A. We're moving 3 right, 1, 2, 3. And then we're moving 3 down, 1, 2, 3. And this is where our A prime would end up. Now, because we're moving all of the points the same distance right and down, the size of our shape should be the exact same. 1, 2, 3 right, 1, 2, 3 down, B prime. 1, 2, 3, 1, 2, 3, C prime, and then 1, 2, 3, 1, 2, 3, and D prime. So again, on all of your shapes, you need the labels of the letters. So if you did not have A prime, B prime, C prime, and D prime on your final shape, you would not get full credit. And that is what our picture would look like. Okay, so this is an example where you have to graph using the rule. The next one, we're going to write a rule for the translation of triangle ABC to ABC prime. Again, all of your rules have to start with X and Y in parentheses, and then an arrow indicating what we are going to be doing to each of our points. So for this one, you are going to pick one point from each of the shapes that has the same letter. So I'm just going to choose A and then A prime. And we are looking, what are we doing with that shape? So the first thing you're going to look is, are you going left or right with your x's? So remember, your x is positive if you're going right and negative if you're going left. And we always start with the letter without a prime. So we're going to start at A. And to get to A prime, we moved 3 units left. So that means we are going to have our x minus 3. Then if we look for our y's, if it's positive, we're going up. If it's negative, you're going down. This one, we are going up 2 units. So we're going to have y plus 2. So your rule is always going to have 2 x's and 2 y's. One in the beginning and then one in the final part of the rule. So all of this is what is expected when you are asked to write a rule. If you're missing the x and the y at the beginning, you will lose points. So make sure you are including both parts. Okay. So now these next two, you should try to do them on your own. So pause and then go through the problems. Once you have your answer, you can look on here. Okay, so for number 1, we are going to draw the vertices P, Q, and R. So P was at 4, 2, 3, 4, 1, 2. Q was at 6, 2. And then R is at 4, negative 2. And this is our starting pre-image. They want us to find the image of each vertex after the translation, xy with x minus 4 and y plus 1. Now, one thing, if you don't have a graph, you can still figure out where the coordinate points would be by just plugging in each of your x's and your y's. So point P, that was at 4, 2. If we plug this into the rule, we would have 4 minus 4 and then 2 plus 1. And we got the minus 4 and the plus 1 from our rule. This would tell us where P prime would be at. So this one it would end up being at 0, 3. And if we check, remember -4 on the x is down, and the +1 is, oh, I am so sorry, I said that wrong. -4 on the x is to the left, and then the +1 is up. So if we move P 1, 2, 3, 4 left and up 1, we end up at 0, 3, which we found mathematically over on the left. And you can again do this for all of your points, or you can use the graph. Sometimes you won't have a graph and you'll need to plug it in. So this one, we're looking for the image, we follow the rule. If we were looking for the pre-image, so if we started at P prime of 0, 3, and they asked us to find P, we would do the opposite of the rule. So we would do 0 plus 4, and then we would do 3 minus 1. And this would bring us back to the image of point P of 4, 2. So you follow the rule to get to the image. You do the opposite of the rule to get to the pre-image. All right, so now I'm just going to finish my graph over here. So we would have Q prime here, and then R prime down here. And then there we have our image. So make sure your points are in the correct spot, and then you can move on to your next question. This one, they already graphed it for us. +8 means right 8. +10 means up 10. So each of these, I'm going to start with point A. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there at the top. And don't forget your primes. And the size of our shape isn't going to change. So that means B should be 3 to the right of it. And then 1, 2, 3, 4. D should be 1, 2, 3, 4 below it. So again, our shape size does not change. So once you know where one point is, you should be able to figure out where the rest is. So make sure you check the graph on that one. Okay, so those are translations. The next thing we're going to go over, actually, I forgot that these were on here. These ones we're going to go over next time when we are together. So for center of rotation, angle of rotation, you can skip these ones. These are going to be easier when I'm there in person to show you how to do them. So don't cross it off. We will come back to this. So you can just skip to the last page of the notes. So this one is a rotation theorem. So rotating, for this, it is going to be helpful to know what a rotation is. So the center of rotation is just the point we are rotating about. And then the angle of rotation is how far you rotate. For our rotations, we have two directions. We have clockwise and counterclockwise. So for these, we're just going to draw our coordinate grid. One to demonstrate clockwise and then one to do counterclockwise. When we're measuring degrees, we're always going to start at 0 degrees at the positive x-axis. Counterclockwise goes the opposite direction of a clock. So that would be going this way. And we're going to be doing increments of 90. And counterclockwise is our default. So we're always going to default to counterclockwise. So if it's a positive number, we are going to be going counterclockwise. If it's a negative number, or you are told, you're going to go clockwise. So again, our default, the most common one we're going to use, is counterclockwise. And then clockwise is going to be negative or the opposite. So this one we would go negative 90, negative 180, negative 270, and then negative 360 is over here. So these are the two directions that we are going to use. We are going to do this part when I'm there in class because you're going to need some stuff to work through this, and I'm just not there to give it to you today. Okay, so then now that you know that rotating, we're just turning a shape. We're not changing the size, but we are turning it. So think about the hand on a clock. It never changes size, but it is pointing in different directions throughout the day. So we're going to be doing that two different pictures. So because it does not change its size, we're going to have an isometry, which means we're moving it, but we're not changing how big it is. So for example, AB, and then, oh, these two letters are in the wrong spot. This one, we'll cross that off. That should be a C, and this one is a B with our primes. So when you rotate it, AB and AB prime are going to be congruent to each other. And then AC prime and AC are going to be congruent. And then BC and BC prime are congruent as well. So when we rotate it, the size is the same, just the angle is different. So for number 4, the quadrilateral is rotated about P. Find the value of Y. So we took this point here and we rotated it. And the point above it is still going to be the point above it in the other shape. So that tells us 7y is going to be congruent to the 3x plus 1. So we can set those equal. The top part of the shape going around it, those two parts are congruent in both of them, but we don't know the side in our image. So then if we go to this other part where we know that side is 6, if we rotate that in our other shape, that is also going to be the same length. So that shows us that 3x is going to be equal to 6. For these problems, I recommend writing your equations. Pick the one that has one variable, solve that one first, and then use that to solve your second equation. So in this one, we get x is 2. We can plug that right there. So then we would have 7y equals 3 times r2 plus 1. Then we're able to solve for both of our variables. And we get x equals 2 and y equals 1. Okay, so go ahead, try number 4 or checkpoint 4 on your own. Once you have that, hit play and double check your answer. Okay, so we rotated this one 180. So if we start and we look where these points went, that 3B is going to be congruent to the side that we don't know in our first triangle. So then if we look at the top, that 4B is going to be congruent or equal to the 2A plus 6. And if you notice, I'm color coding so I can make sure that I'm pairing up the correct side. So if you want to color code or highlight or find a way that you know you are pairing up the correct sides, use whatever method works best for you. And that leaves this bottom piece on both of them to be congruent to each other, where we have 15 equals 3a. And choosing the equation that has one variable, I'm going to solve our second one, divide both sides by 3 to get 5 equals a. Then we can plug it into our first equation. That gives us an answer for our b variable. So 4b equals 10 plus 6, 4b equals 16, which gives us b equals 4. Okay, so that's everything. Because we skipped the rotation part, you are going to be able to, don't cross them off because we will eventually do them. You can skip the parts with rotations on your homework. So let me just pull that up so you know exactly what problems you can leave blank for now, and then we'll do them on, let's see, Thursday. geometry, and then we will go Unit 6 homework. Okay, so you should be able to do, so you're going to skip number 7. Oh, wait, no. You can do the whole front page. Ignore that. Do the whole front page, and then you should be able to do, actually, everything except for the last page. So do all of it except for the last page on your homework. So the first page from back, do those, and then skip the last page for now. And then we will go over that first thing on Thursday. All right, so I'm going to let you get started on that, show the sub your completed notes, and then you have the rest of the time to work on your homework.